Hopefully you were able to identify that the two factors were negative 24 and positive 3. So we'll split the b term, just like we did last unit, and then we'll find the greatest common factor of the first two, which is 2z, leaving behind z minus 12, and the greatest common factor of the second, which is positive 3, leaving behind z minus 12. All right, so from there we can create our two factors, which are 2z plus 3 and z minus 12. Again, all equal to 0. Once you've created your two factors, we'll set them equal to 0. So we have 2z plus 3 equals 0. That's one factor. My other factor, z minus 12, equal to 0. Then we solve each of our two equations. We'll end up with z equals 12 and z equals negative 3 over 2. All right, to find our final answer, we always write the smaller solution first and the larger solution second. So negative 3 over 12, negative 3 over 2, and 12. When you factored number or letter C right there, hopefully you identified the two numbers that multiply to negative 160 and add to negative 27 are negative 32 and 5. If you didn't use the method that I used here to write out all of the factors by hand, I'd really recommend you use a graphing calculator to find those factors. After we've split that b term, we can take our greatest common factors. So again, we'll have 4m times m minus 8 and 5 times m minus 8. So creating our two factors, you should have had 4m plus 5 and m minus 8 equals 0. You might be noticing that this last process of setting equal to 0 is the same every time. If the a term equals 1, it'll just be the opposite side. So m minus 8, well, the solution's going to be positive 8. If there is an a term bigger than 1, then that'll become a fraction. And here we have negative 5 over 4. All right, so our final solution, negative 5 over 4 and 8. Before you try D, E, and F, I want you to take a look and identify what might be different about these problems. Hopefully you identified that they're not equal to 0. So any situation where we don't have the quadratic set equal to 0, we'll have to use inverse operations to create an equation equal to 0. So here we subtract 21 on both sides, and then we end up with p squared minus 4p minus 21 equals 0. Once you do that, well, now we have an equation we can factor. P minus 7 and p plus 3. Once we've factored, we can set both factors equal to 0. You'll notice that I kind of skipped a step right here. Again, if we notice the a term is 1, we know those factors are going to become the opposite. So the final solutions are negative 3 and 7. Remember, these would be called solutions, roots, zeros, and x-intercepts. All four of those words mean the same thing. Go ahead and try part E and part F, and then come back to check your work. For part E, you first should have moved the 12 to the other side. After that, when we factor we're looking for two numbers that multiply to 24 and add to negative 11. So that's negative 8 and negative 3w. Factoring out our greatest common factor, we have 2w times w minus 4 and negative 3 times w minus 4. Our two factors become 2w minus 3 and w minus 4. And as we set those equal to 0, we'll we'll end up with factors of w equals 4 and w equals 3 over 2. Even if both factors are positive, remember to write the smaller one first. You might be asking, can we use decimals, Mr. Bohm? And totally. You can do it either way that you like. Finally, for f, when we move the 16 to the other side, we'll notice that we have a binomial. In fact, we have perfect squares. If you forgot, you could use our normal factoring method, but this is a really important point from last unit that we focused a lot on. If you have binomial difference of perfect squares, we can just quickly factor to find 3x plus 4 and 3x minus 4. You might notice, as we solve each of these 3x plus 4 and 3x minus 4 equals 0, that the numbers will end up being the same number in opposite signs. In this case, x equals negative 4/3 and positive 4/3. When you write your answer for something like that, it's appropriate and okay to write x equals plus or minus 4/3. You could write them separately, saying x equals negative 4/3 and x equals positive 4/3. Really, whatever works best for you. All right, go ahead and try the next page, G, H, I, J. And I'll put the answer to all of those as a PDF inside of Google Classroom. And you can check your work on each. Before signing off of the video, let's talk about the real-world application. So Michael and James are constructing a frame for a rectangular picture from DC. They want to frame the frame to be the same width all the way around, and a total area of the frame to be 315 inches squared. What should the outer dimensions of the frame be? All right, so we're talking about the outer dimensions of the frame. So before we even start, let's just get on the same page. So we're looking at finding this part right here. Okay, what should our dimensions be of that outer frame? So first thing we're going to want to do is let's figure out how much is the width and the length here. Looking across, I see that it's 17 inches across from here, not all the way to the edges, but from here to here is 17 inches. We also notice there's an X right here and an X right here. So this width would be 17 plus 2x. In the other direction, the height of the picture is 11, and then there's an X on the top of the frame and an X on the bottom. So this would be 11 plus 2x. All right, so they know the total area of the frame and the photo is 315. So we know that the area equals 315. We also know the area is the length times the width. So if we filled that in even further, well, the length, 17 plus 2x, and the width, 11 plus 2x, all is going to be equal to 315. So if we were going to try to continue solving or factoring or working towards getting the solutions for x, we'll start by distributing or using FOIL. All right, so 11 times 17 is 187 plus 34x plus 22x plus 4x squared. We can rewrite all of this information into standard form as one trinomial, 4x squared plus 56x plus 187 equals 315. And then we can think about how we would solve. To solve this, well, we could try to factor, but it's not equal to 0. So before we can start factoring, we'll have to subtract and set our equation equal to 0. So we'll have 4x squared plus 56x minus 128 all equals 0. Some alarm bells should start going off in your head. Since all of these numbers are even, we know there's a GCF. If you investigate further, you'll find, well, that GCF is actually 4. And that leaves behind a trinomial with an a term equals 1. So 4 is the greatest common factor, leaving behind x squared plus 14x minus 32. If we wanted to keep solving from there, we'll have 4x plus 16 and x minus 2. To solve when you have a greatest common factor, well, we can just ignore it. It doesn't really matter. Our two factors are x plus 16 equals 0 and x minus 2 equals 0. So if we solve both of those, we'll end up with x equals negative 16 and x equals 2. So let's take a second and think about that. We have a real-world situation. We have this picture frame 17 by 11, or the picture is 17 by 11. It's asking us, what should we fill in for the outer frame? So would it make sense for x to be equal to 2 or negative 16? Hopefully you're thinking to yourself, that wouldn't make sense for x to be a negative number. A length can't be negative. So that means x has to be 2. So all around the frame, there's going to be a 2-inch border. Once we do that, we know our final dimensions. So going across, well, 17 plus 4 would be 31 inches. 21 inches. The height going up and down we know is 11, plus the frame has 2 inches on the top and 2 inches on the bottom, so that would be 15 inches. So the final answer is the dimension should be 21 inches by 15 inches. All right, so hopefully you've gotten a good sense of how to solve quadratic equations by factoring. I should be back for period 4, but if I'm not, continue practicing, try your homework, and start in on Delta Math.